All right, so we are going to go ahead and jump into the second section in Unit 9, which is rewriting logarithmic expressions using the properties that we just talked about in our last section, okay? So our topics here are going to be expanding logarithmic expressions, condensing them, so either writing them as multiple terms or taking multiple terms and writing them as just one, and then we're also going to look at the change of base formula, okay? All right, so just as a refresher of the rules we learned in the last video, that a multiplication inside the log turns into addition, a division inside the log turns into a subtraction of log terms, and an exponent on the inside value of the log can come down as a coefficient of the log. Okay, so we're going to use these in both directions. First, we're going to look at expanding, okay, and we'll do some examples and some practice, and then we'll look at condensing. So when we look at expanding, we're basically looking for a multiplication, a division, or an exponent inside the log so that we can expand it to look like this side. Okay, then when we get to condensing, we're going to be looking at this side and seeing if we can shrink it back down into one log term. All right, so let's look at this one. Here we have the natural log, or the ln, of 9/2 b to the 5th. And the first thing that I notice is that I have two separate bases in here. I have 9/2 and I have b to the 5th. So if I have a multiplication, I know that I can expand that into an addition of natural log terms. So I'm going to rewrite this as ln of 9/2 plus ln of b to the 5th power. Okay, and then I want to look to see if I can do anything further. So if I look at this first natural log term, I have 9/2. Remember that fraction line represents division. And division can be rewritten as a subtraction of natural log terms, right? So I can expand this one to be ln of 9 minus ln of 2, right? The one that came from the denominator is the one that gets subtracted, okay? So I've expanded this term. Then I look at this one. The only thing I can do to this last term is to take that exponent and bring it down as a coefficient. So I have a positive ln of b term. Okay, remember ln is base e, right? This is log base e, and e is not going to cancel with a 9, a 2, or a b. So we're just going to leave it like this. Okay, let's look at another one. This one I want to do the same thing, and I can see right away that there's a multiplication of 3 and x, but right now they're stuck under a square root. So I need to get rid of that square root, and I can't do it when it's written in radical form. So I want to change this from radical form, or meaning, you know, it's written as a root, right, or a radical, to a fraction exponent. Okay, and remember, fraction exponents, or rational exponents, represent power over root. Okay, or in other words, this is the number of copies. So if you have something squared, something cubed, something to the first power, and then the root is the type of radical that you have. So is it a square root? Is it a cube root? Okay, so here we have a square root. So I can rewrite this as log of 3x, and then I want to write the power that I can get from using a square root. So notice here, 3 and x, I only have one copy of them. So it's to the first power, because I only have one copy, okay? And then it's over whatever root or type of radical I have. Since this is a square root, I'm going to use a 2. Okay, so I can rewrite this as log of 3x to the 1/2 power. Now I still can't do my multiplication yet because it's stuck inside this parentheses and the 1/2 is being applied to that whole thing. Now, if this 1/2 was, say, just on the 3, then I could go ahead and expand this into multiplication and then get rid of the 1/2. But since the 1/2 is around all of this, I need to go ahead and move that 1/2 down first. So this gives me 1/2 times log of 3x. Okay, so just bringing that down. Now I can take care of this multiplication. Multiplication turns into an addition of log terms. So I'm going to get log of 3 plus log x. And notice here, this 1/2 was being multiplied to this log 3x. So if this log 3x becomes 2 terms, I still need to be able to apply that 1/2 to both terms, okay? Because if the 1/2 was multiplying this, if this turns into 2 things, it still needs to be multiplying by that, okay? All right, and then the last thing I'm going to do is just distribute this 1/2 in so that it's on both terms. So I have 1/2 log 3 plus 1/2 log x. And we just leave it like that. That's as far as we can go. Okay, let's look at one more. So at the top of this page, I have log of x over 3 times y plus 2. First thing that I notice is that I see a multiplication in here, right? Multiplication turns into an addition of log terms. So I'm going to go ahead and expand this and write it as log of x over 3 plus log of y plus 2. So now that I have that multiplication expanded, now I want to see if there's anything I can do with these two terms. So if I look at this first one, my inside value, I'm looking for a multiplication, a division, or power. This one has a division, right? And division turns into subtraction. So I can rewrite this term as 2 log terms as log x minus log 3, right? And then my last term, if I look at simplifying it, it has an addition inside. And remember, we don't have rules for addition. So the only thing I could hope to do here is pull out a greatest common factor to create a multiplication, but I have no greatest common factor between y and 2. So there's nothing I can do with this last term, so I'm just going to leave it as is, plus log of y plus 2. And we just leave it like that, okay? All right, so there are 2 examples or practice problems for you down at the bottom of this page. So go ahead and pause the video and work those out. If you get stuck or if you're ready to check yourself, unpause the video and we'll go over them. All right, so on the first one, we see that we have a multiplication. We have the square root of 7 times z, and that multiplication turns into addition. So we're going to break it up into 2 separate terms. And then notice this 7 has a radical. It's stuck under a radical, right? So we can write that as power over root. So I have 1 copy of the 7 and it's under a square root. So I can rewrite this as log of 7 to the 1/2. Notice the root is only on the 7. So we can't work this one like the example that I did where it was the whole thing raised to the 1/2 power. Okay, only the 7 has the 1/2 power because only the 7 is underneath the radical. Okay, so once you expand that multiplication, then you can bring that 1/2 power down in front of the log 7 term only. Okay, so this one should not have a 1/2 in front of it. Okay, all right, on number 2, I see that we have a division. That's what I noticed first anyways. A division turns into subtraction. So I'm going to do log of the numerator minus log of the denominator. And then once I do that, notice this numerator log has a multiplication. I have 3 times x to the 4th. So I can expand that into addition. So that gives me log 3 plus log of x to the 4th minus log t. And then the last thing I have to do is to take that exponent, which was applied only to the 4, and bring it out front. Okay, so don't bring the 4 down at this step because the 4 is only an exponent on the x, not on the 3. So you can't bring that 4 down until you have a log with just that x in it. Okay, once you have a log with just that x in it, then you can bring that exponent down. Okay. All right, so all the examples we just did was taking one log and expanding it into many logs. So now we want to look at the opposite direction where we take many log terms and expand them back, or sorry, condense them down into one log term. So let's look at some examples. We're condensing them into a single logarithm, okay? So the first thing I want to do is check to see if I have coefficients, because just like on the last practice problem, the power, the exponent, was the very last thing that we brought down. When we go the opposite direction, it's the very first thing that we do. We want to take those, those coefficients and put them back up into the exponent. So then we can condense with our addition and subtraction. So notice here, we do have an exponent. We have a 2. And I'm going to go ahead and just write this over here so that I have as much room as I want. Plus 2 ln 5 minus ln 15. So the first thing I want to do is take this 2 and put it back up into the exponent. So now it's going to look like ln of 30 plus ln of 5 squared minus ln of 15. Okay, and then I want to go ahead and start condensing. So I have an addition and I also have a subtraction. So I'm going to do it in 2 separate steps. If you can do it all together once as one step, that's totally fine. But I see that this is an addition, and I know that addition can be condensed to multiplication. So I can write this as one natural log term if I just multiply these 2 numbers together, right? So 30, and I'm going to go ahead and change that 5 squared to a 25. Okay, and then I still have this minus ln 15. Okay, now I have a subtraction. So subtraction, remember, condenses to a division, right? And the term that's being subtracted, that's the term that's going to end up on the bottom. So I'm going to go ahead and rewrite this as one log term. So ln, I'm going to go ahead and do 30 times 25 is 750, and then over the 15, because that one's the one being subtracted. And then I just want to see if this simplifies. 750 divided by 15 is actually 50. So I end up with the ln of 50. Okay, and we just leave it like that. Let's look at another one. Okay, on this next one, same idea. We want to get rid of coefficients first. So I'm going to put this 3 back up in the exponent. I'm going to put this 4 back up in the exponent, and the last one didn't have one, right? So this is going to give me ln of 10 cubed minus ln of 2 to the 4th minus ln of 5, right? Excuse me. So I want to go ahead and start condensing, and I'm also going to simplify these numbers as I go, right? So the first thing I see is this is a subtraction. Subtraction condenses into a division, and the one that's negative is the one that goes to the bottom. So when I condense these 2 natural log terms, I'm going to have the ln of 10 cubed. Now 10 cubed is 1,000. So I'm going to go ahead and write this as 1,000 over 2 to the 4th. 2 to the 4th is 16. Okay, minus ln 5. Okay, and then again I have another subtraction, right? Another subtraction also condenses into division. Okay, now when we do division, we send the one that's being subtracted to the denominator, right? And notice here we already have a denominator, so when I condense these, I'm going to go ahead and just tack on this 5 to the denominator that already exists in here by just multiplying it down here on the bottom. Okay, so I end up with ln of 1,000 over 16 times 5. Okay, and then we're just going to simplify. So ln of 1,000 over 16 times 5 is 80. And then you can either punch this into your calculator, those of you who are aware of your fraction button, right? Which my fraction button on this calculator is this A, B over C. So if you type in 1,000 and then use your fraction button to put it over 80, it will reduce it for you. It gave it to me as a mixed number. So I'm going to go ahead and use the second function on my fraction button to go ahead and change it so it reduces it for me. So this just ends up being 25 over 2. So this is equivalent to ln of 25 over 2. Okay, and I'm not gonna like expand this, right? Because the instructions for these were to condense it into a single logarithm. So even though I have a division in here, that's okay. I don't want to expand it because I want it to be written as one logarithm term. So we get natural log of 25 over 2. I think you can leave it like this. When I was working them, it was allowing me to do that. If it doesn't like that, you can go ahead and just do 25 divided by 2 and write it as the natural logarithm of 12.5. But I'm pretty sure it allows you to just leave it as a reduced fraction. All right, so let's look at this last one. This last one, again, I want to start by moving my coefficients back up into the exponent. So I'm going to go ahead and move my 7 back up here, my 1/3 back up, and my 1/2 back up. So this looks like log of w to the 7th power plus log of 8 to the 1/3 power plus, no, not plus, just kidding, minus log of 4 to the 1/2 power. Now remember, fraction exponents represent radicals, okay? So I'm going to go ahead and just say change fraction exponents back to radical form or simplify on your calculator. Okay, because most of the ones they give you, this will simplify. So I'm going to show you how to do it with changing it back to radical form, but then you can also just raise 8 to the 1/3 power on your calculator if you prefer. Okay, all right, so I'm going to rewrite it. So I have log of w to the 7th power plus log of, remember this represents power over root. So I have 8 to the 1st power, and I'm taking the cube root of it. So I have the cube root of 8 minus log, and here again, power over root. So I have 4 to the 1st power. I'm taking the square root of it. So square root of 4. Okay. And then I can go ahead and just simplify those because I know what the cube root of 8 is, and I know what the square root of 4 is. So this gives me log of w to the 7th plus log of cube root of 8 is 2 minus log of the square root of 4 is 2, right? And notice what happens before I even start, condensing and doing all of that. What I see here is that I have a positive log 2 and I have a negative log 2. These are like terms, right? Combine like terms, okay? And notice here, when I combine like terms, it combines to 0, right? Because they're opposites. So these just cancel out, and I'm just left with log of w to the 7th power. And I just leave it like that. So I don't even have to use my addition condensing and my subtraction condensing to be able to write this as a single logarithm. Neato Cheeto, right? I can tell you're thrilled. I can feel it through the computer. All right, so on the next page, there are 3 for y'all to try. So go ahead and pause the video. And if you need help or you get stuck, go ahead and play it. Hopefully for future generations watching this video, this typo will be fixed. But for this one, sorry, it is not. This is not supposed to say ln. This should just say regular log 3. So sorry about that for those of you who have this version. Hopefully the rest of you who are watching this in the future have a packet of notes that does not have typos. So, all right, try those and we'll check back in here in a minute. All right, so let's go ahead and look at these practice problems. On the first one, we start by taking the coefficient, putting it back up into the exponent. Notice here we had two bases inside this quantity. So we have to make sure we square both of them. So square the 7 to get 49, square the r to get r squared. And then because we have an addition, we can condense this to multiplication. So we just multiply k times 49r squared and write it together. So we get the natural log of 49kr squared. Everybody okay on number 1? All right, number 2, I already identified you about my typo. That should have just been a regular log. We're going to start by taking the 2 coefficient and the 3 coefficient and putting them back up into the exponent. Once I have them back up into the exponent, I'm going to go ahead and simplify those numbers. 9 cubed is 729. 6 squared is 36. And now that these are simplified, I can start condensing. So log of 729 minus log of 36, subtraction condenses into division. So I end up with log of 729 over 36. And I just brought down that third log term. Now this I simplified in my calculator by using my fraction button to reduce it to 81 over 4. And then I have log of 81 over 4 minus log of 3. Notice this one's being subtracted. That's going to send it to the denominator when I condense it because it condenses to division. So I'm going to go ahead and tack on this 3 down here with this 4. So when I do that 4 times 3, my denominator is now going to be a 12. Okay, so log of 81 over 12, if I reduce this fraction, gives me log of 27 over 4. Okay, all right, let's look at the last one. Number 3, I want to start by taking my coefficients and putting them back up into my exponent. So 2 goes up into the 9, 5 goes up to the 3, and the last one didn't have one. So I end up with a 9 squared and a 3 to the 5th. So that's going to simplify to log 81 minus log 243 plus log 4. Okay, and then I'm just going to start from left to right condensing. So a subtraction turns into a division. So 81 is going to be on top, 243 is going to be on bottom. So I end up with log of 81 over 243. And then I have this last term over here plus log 4. Remember, addition condenses into multiplication. So I need to multiply these inside numbers. This one I went ahead and simplified on my calculator to 1/3. So when I multiply 1/3 times 4 to condense it, I end up with log of 4/3. Okay, so we've talked about expanding, we've talked about condensing. The last thing we have to talk about in this little section is the change of base formula. So remember how we talked about we only have 2 buttons on our calculator that can do logs, which is our log button, right, and our ln button. So I'm going to write here, this is our log button, and this is our ln button. Okay, what the change of base formula does is it allows us to take any log with any base and convert it into a different base. Now, I don't know why you would want to convert it into any base other than log or ln, because usually when we convert them, it's so that we can use our calculator. So, but here's how it works. Whatever you have log base b of m, you can change it to a different log base by using the new log base of your inside number over your new log base of your original base. Okay, so this is the original base, and this, I'm going to call this the inside number. Okay, so to change your base, you change it to whatever new log base you want, and you evaluate that new log base at your inside number, divide it by your new log base of your original base. So I don't know why we would use this one, but I would want to specifically change it to just a regular common log or a natural log. So to common log, I would just do log of m over log of my original base. And this is something you should be able to do on your calculator. Okay, same thing with ln. ln of your original inside number over ln of your original base. This will be equivalent to that original expression. So let's just look at one. Notice here it says calculate to 4 decimal places. So we're going to go ahead and calculate. Now, it doesn't matter if you change it to a log or to an ln. If you're just trying to get a decimal approximation, you can do whichever one you like. So what we need to do, I'm going to just choose log. I'm going to change this into a regular log so I can use a log button on my calculator. And the log says we do log of our original inside number which here is 36, over log of our original base, which was 5. So some of you guys' calculators will allow you to just type all of this in at once and get an answer. Some of you may have to calculate each of these individually. I encourage you to store your answers if you have to do it one step at a time so that it keeps all of your decimal places until the very end. Don't round till the very end. Okay, so if you have to work it out one step at a time, this should give you 1.556 and some more stuff. The bottom should give you 0.698 and some more stuff. And then when you divide those two numbers, or if you work this out all in one step, you should get 2.22656 and some more stuff, right? We want to round it to 4 decimal places. So my 4th decimal place is this 5. Notice there's a 6 behind it, so that's going to bump it up. So this is approximately 2.2266. And we just leave it like that. Okay, same idea on these next ones. Go ahead and move it up. This time I'll change it to a natural log. Now it doesn't matter. You could change it just to a regular log again. The reason I'm choosing to do natural log is because I see an E there. So I'm going to go ahead and use ln of my original inside number, right? Original inside number, which here is E, over ln of my original log base, which is pi. Now, E and pi both have buttons on the calculator, so that's what you should use, right? But we should be able to do the top in our head because ln and E are inverse functions, so they cancel, right? So on top, we should have a 1. And then ln of pi, if we type that into our calculator, ends up being 1.144 and some more stuff, okay? And then again, if you can do this all in one step on your calculator, that's fine. Whenever you divide these two numbers or you do this in one step, we should end up with 0.87356 and some more stuff. Again, we're rounding to 4 decimal places for these examples. Make sure you pay attention to what Newton asks you because sometimes it changes. It may not be 4. 1, 2, 3, 4, which is our 5. There's a 6 behind our 5, so that's going to bump up to 0.8736. Okay, let's look at one more. I have log base 1/4 of 7. So this means I'm going to do log or ln. It doesn't matter which one. Okay, I'll just do log. Sure, why not? Log of my original inside value, which is 7, over log of my original base, which is 1/4. Now you can type in 1/4 or you can use 0.25. It doesn't matter. Okay, either way. Then you can punch that all into your calculator or you can work it out step by step. It doesn't matter to me. Excuse me, either way, as long as you can do it accurately. So on top, if you are working it out step by step, you should get 0.845 and some more stuff. On the bottom, when you do log of 1/4, you should get negative 0.602 and some more stuff. When you divide these, or if you did it all in one step, we end up with negative 1.403677 and it keeps going. We're going to round it to 4 decimal places, which is where my 6 is. Notice I have a 7 behind it, so that's going to bump it up. So this is approximately 1.4037. Okay. All right. So on these, we wanted a decimal. So if we want a decimal answer, it really doesn't matter which you use. You could use log or ln so that you can punch it into your calculator. But they might also have you enter your answer just written as a different log base. Like this one, it says change log base 17 to a quotient of natural logarithms. So natural logarithms, that's our ln, okay? So we're just going to use this change of base formula with ln, but we're not actually going to simplify it. We're just going to keep it as a quotient, okay? So this means we're going to do ln of our original inside number, which is 17, over ln of our original base, which notice here, if there's not a base written, that's an implied 10. Okay, so ln of 10. And then we would just leave it like that. Okay. Same thing on this next one. We have log base 8 of t. and we want to leave it as a quotient, but this time we want it written as a common log. So a common log is log base 10, which is the one where we just don't write the 10, right? So we do log of our original inside value, which here is a t, over log of our original base, which is an 8. And we can just leave it like that, okay? So on the next page, there are 3 for you to try. So go ahead and try those. Pause the video, and then when you're ready, play it again. Okay, so here we go. Practice. This one, we want a decimal answer for this log, and we want it rounded to the nearest 10th. That is 1 decimal place. So I worked it out here using a common log and also using ln, just to show you'll get the same thing either way. So either way you worked it, you should have ended up with 0.6. Okay. On number 2, we wanted to write this as an expression using common logs. No, natural logs. Natural logs. So ln. So we do ln of our inside number over ln of our original base, and we just leave it like that. Okay, so that should have been the 4th choice. And then on number 3, we wanted to find the actual value and round it to 4 decimal places. So again, here you could have used log or ln, and we do log or ln of our original number over log or ln of our original base. Either way, you get the same thing. This is wanted you to round to 4 decimal places, so we should have got negative 0.7611. Okay, so that is the end of this section. So you should now be able to complete rewriting logarithmic expressions using properties in your Alta Newton homework. If you have any questions, please let me know. I am happy to help.